Hey folks, in today's video, I'm gonna show you how to draw skeletal structures or bond angle structures. So first of all, they're called bond angle because we only show the bonds and estimated angles between the atoms. And the reason why we need to learn how to draw skeletal structures is because they give a simple and quick way to represent large and complicated organic molecules, which otherwise would take a lot of time to draw using loose structures. And imagine you're having a chemical reaction and you have to draw the same structure over and over again. So using skeletal structures will save you a huge amount of time. So in skeletal structures, each line represents two carbon atoms and a bond between them. And since carbon atoms are represented by these 2 points, we wouldn't show it because we already know what's in there. So for example, here we have a skeletal structure. So we know that each of the starting and intersection points represents a carbon atom. So we have a total of 4 carbons, and that is actually the skeletal structure for butane. So now you might be asking what happened to the hydrogen atoms. So actually hydrogen atoms are assumed to be in there, but they're not drawn out to save time, and that is the whole purpose of the skeletal structure that we highlighted at the beginning. So to find the number of hidden hydrogen atoms, all you have to do is subtract the number of lines attached to the carbon from the total number of bonds that carbon can make, which is 4. So it's going to be 4 minus the total number of lines around the carbon. So for example, here this carbon is attached to only one line, which is the carbon-carbon bond. So to find the number of hidden hydrogen atoms, it's going to be 4 minus 1. So it's going to be 3. So this carbon has 3 hidden hydrogen atoms. However, if we look at this carbon, it has 2 lines, so it's gonna have 2 hidden hydrogen atoms. So one last thing that you need to know about hydrogen atoms, that they're only not drawn if they're bonded to carbon atoms. But however, if they're bonded to any other atom, they must be drawn. So for example, here we see the skeletal structure of ethanol, and in this case the hydrogen atom has to be shown because it's bonded to a non-carbon atom, which is oxygen. So one more thing to note here, this ending is not a carbon atom, so don't make a mistake when counting the total number of carbon atoms in this molecule. So we only consider the ending to be a carbon atom if it doesn't have any atom written next to it. Finally, atoms other than hydrogen and carbon must be shown. So as we have seen in the previous example of ethanol, and also here in the skeletal structure of diethyl ether, any non-carbon hydrogen atom must be shown. Lastly, in skeletal structures, single bonds are just represented by one line segment, double bond is represented by 2 line segment, and triple bond is represented by 3. Also note here that the beginning and the ending of the triple bond are carbon atoms, so don't forget them when counting the total number of carbon atoms. And if you're wondering why didn't I draw it in the zigzag format, that is because these 2 carbons that I just highlighted are sp hybridized. And if you remember from general chemistry, sp hybridized atoms have bond angle of 180 degrees. So drawing it in the zigzag structure will be wrong because the bond angle between those 2 atoms has to be 180 degrees. Single bond and double bonds can be drawn in the zigzag format because each of them has an obtuse bond angle. So in double bonds we have an sp2 hybridized carbons, which has a bond angle of 120 degrees. Also, the carbons in single bonds are sp3 hybridized with a bond angle of 109.5. So now let's do an example. So we're given the loose structure for 2,3-dimethyl butane and we have to draw the skeletal structure for it. So the first thing that we have to do is count the number of carbon on the parent chain. So in this case we have 1, 2, 3, 4. And now to find the number of lines that we have to draw, we just have to subtract 1 from the number of carbons that we have. So since in here we have 4 carbon atoms, we're gonna subtract 1, so we have to draw a total of 3 lines. And here we have the 3 lines, 1, 2, 3. Now let's double check the number of carbon atoms. So we have 1, 2, 3, 4. Now let's draw the substituent. So we have 2 methyl in here, so we're gonna put 1 up here and 1 down here. And that's it. We have the skeletal structure for 2,3-dimethyl butane. Now let's do another practice question. So I highly suggest that you pause the video now and try to draw the skeletal structure for this one by yourself. So now the first thing that we have to do is count the number of carbons in the parent chain. So here we have 1, 2, 3, 4, 5. So now let's find the number of lines. So we just have to subtract 1. So we're gonna have to draw a total of 4 lines. We have 1, 2, 3, 4 lines. Let's double check the number of carbon. So it's gonna be 1, 2, 3, 4, 5 carbons. And now let's add the functional group. So in this case, since oxygen is a non-carbon, non-hydrogen atom, we have to draw it. And since we have hydrogen bonded to oxygen, in this case, we have to draw the hydrogen as well. So here is one more practice question. Also pause the video and try to do it by yourself first. So in this case, we have a triple bond. So remember from before I said for a triple bond, you have to have a 180-degree angle around the triple bond. So in this case, we're going to divide it into two parts. We're first going to draw the first three carbon atoms, and then we're going to draw the last four. So the first three and the last four carbon atoms are going to be drawn in the zigzag format because they have an sp3 hybridized carbons, whereas carbon 3 and 4 gonna have a straight angle of 180 degrees because they are sp hybridized. Thank you for watching, and please if you have any questions leave it in the comments below, and don't forget to subscribe to the channel. Thank you.